guys, welcome back to our channel, The Data Odyssey. In our last video, we understood the journey of data management systems, basically, right? How systems evolved from OLTP to OLAP, and this OLAP itself had three stages of evolution. Now, in this video, we will understand the architecture of any OLAP workload, right? Now, just to revisit the concept of OLAP, let us consider that you yourself is the owner of any supermarket, and you know that every day, every single day, thousands of customers are buying groceries from your supermarket. Now, one fine single day, you just had the thought of why not find out my top selling product, or why not find out the fastest selling product. Now for this you need your past data, right? And the system which allows us to perform analytics, such kind of analytics basically on past data, is OLAP. So OLAP is the system which helps us perform analytics on past data, basically perform analytics on transactional data. Okay, now, how does it enable it? It brings in the transactional data at one place, right? So let's not waste time and dive into the architecture of any OLAP workload. We'll try to understand the architecture of any OLAP workload with the help of an analogy of a supermarket, right? So at the bottommost part of the architecture, you can see storage written, and what it is. It's basically a physical place where all your data is being kept, similar to a library storing books. Now, with respect to analogy of a supermarket, it's the warehouse. Okay, it's the place where all your data are being stored. It's the place where all your products are being stored in a warehouse, and it's the place where all your data is being stored in a OLAP workload, right? Before being placed on the shelves. So, just like a supermarket warehouse stocks goods, data storage stocks information. It's holds the information for any OLAP workload. There are two kinds of storage that we have: is the cloud storage, and then we have the on-prem storage. For cloud, we have multiple vendors in today's world. From Amazon, it's the AWS S3. From Azure, is the ARLS. From Google, is the GCS, the Google Cloud Storage. And then we have the on-prem, the SDFS, which is basically the Hadoop ecosystem, right? Now, this is what storage is all about. After storage comes the file format. What is file format? It's the specific way data is saved, like organizing books as paperbacks or hardcovers. So, in one single word, it's the packaging of data. Okay, and what do I mean by the packaging of data? For example, in a supermarket, product comes in different packaging, right? Cans, in cartons, in bottles. Similarly, data is stored in multiple kinds of format, like in Parquet, like in ORC, like in Avro. Now, of course, these can be further reclassified into row and columnar file format, but right now our focus is just to understand the architecture, right? After file format comes the table format. Okay. Now, what is a table format? It's a structure that arranges raw data into rows and columns for easier access. Now, just look at the word or words, group of words, which is easy access. With let us understand this table format with an analogy to a supermarket, right? So you have the inventory management system within any supermarket, right? Inventory management system. I'm sorry for my bad handwriting. I'm just trying to learn how to write on this writing pad. Okay, digital writing pad, right? Yeah. So a table format is similar to any inventory management system. So a supermarket tracks its stock, right? What products are basically available, or what products are basically sold or expired. So all these kinds of tracking is being done by the inventory management system. And similarly, in the world of OLAP workload, this the task of inventory management system is being done by the table format. It is tracking everything with respect to that particular data. Okay, the various versions of the data. Suppose if you perform a certain wrong kind of transformation on a data and a newer version has been created. Nothing that you don't want the latest version, you want the older version because it's the best form of the data, right? It's the most accurate form of the data, correct? Then you can perform a version rollback on the data, and this kinds of task is facilitated by this table format basically. All right, so this is what table format is all about. And then we have the storage engine. Now as the table format dealt with the inventory management system, now there must also be a stockroom operation operator, right? Or stockroom operations person, right? Correct. So what is a storage engine basically? A warehouse doesn't just store product in a supermarket, right? It also manages its placement, its retrieval, its organization. There's a person who's maintaining or tracking all of these things. Like that individual ensures that the product is being placed in such a manner that its retrieval process is easier, right? We get it in the least possible amount of time. So this entire retrieval process is easier when the data is written efficiently in the storage, right? And this is what the storage engine does. It's a tool that handles the reading and writing of data from storage efficiently. And then we have the compute engine. What is a compute engine? It's a processor that analyzes and performs calculation on your data. Now, with an analogy to a supermarket, what is a compute engine? It's basically the checkout counters. Okay, it's basically the checkout counters. Now, customers bring items to the checkout where cashiers are there, right? And these cashiers process the orders and then finally give the bill to the customers. See, customers with an we are seeing customers as an analogy, but in the world of data it's basically the queries. So when you perform any query on that bigger chunk of data, this is being sent to the various computing engines. For example, this Spark, you can see an engine or a processing framework, which is Spark. It will perform all kinds of analytics on the top of the data and then finally return the output. This task of Spark is being performed by the cashiers at your counter, and this task of queries are is being performed by the customers basically, right? So the customers brings in the goods or the products which he wants to, or she wants to buy to the counters, and then these cashiers process them and then finally give the bill, right? Similarly, in the world of data, the queries are is being sent to the computing engine or the computing framework, which can be Spark, or it can be Trino, it can be Dreamio. Multiple computing frameworks are there, and finally we get the output of the query, right? Finally, we need to go through finally there's the last component that we need to study, and it's the catalog. So what is a catalog? It's an index that tracks where your data is stored and how it's getting organized. So it's very similar to the product catalog of any supermarket, right? Now each product in a supermarket does have a barcode, right? The cashier, what does the individual do? He or she just scans this barcode, and then the relevant price for that particular product is actually shown to the cashier, using which he or she can calculate the final amount of all the products being brought. Similarly, in the world of data or the OLAP workload, the catalog is the place where you get to know where your individual data is actually kept. This catalog helps us identify that particular place. So it's very similar to a product catalog of any OLAP workload. All right. So to summarize all these things, these components ensure that data is easy to store, find, and analyze, just like a well run supermarket, basically. And yeah, so that's the entire OLAP architecture that you can see. And now we'll just try to understand the difference in the architecture of these three stages of evolution that we have had in the world of OLAP workload, right? We have seen in the last video that first the data warehouse came into existence in the world of OLAP, then the data lake, and if you go through the last video, then we had the data lake house, right? just you can see on the screen over here. Okay, but prior to going to coming to this slide, first let us understand that what is the difference in the architecture of data warehouse, the data lake, and the data lake house. So what you need to identify in all these architectures, that these three blocks are the ones which have a major difference, and also this area is the one which have a major difference in all these architectures. See, storage is present in both data warehouse and data lake. All right, file format is there in both data warehouse and data lake, because you need a particular file format to store your data, right? But in the world of data lake, what's happening, that the table format is of smaller size. And what does the smaller size signify? It signifies a less importance of table format. That means in the world of data lake, what happens, you do not give importance to structure of your data, which data warehouse does give. Another difference you can find on the screen is the storage engine. Okay, so there's a tight coupling between the storage and the compute engine in data warehouse, but there's a decoupling between storage and compute in data lake. And what does it mean? Basically, this means that if the storage increases, you do not necessarily need to increase the compute in data lake, which you had to in data warehouse. We have seen this in the last video. All right, and another important thing is that you are giving a lot of importance to the structure, and the entire asset transaction properties is also being given relevance in data warehouse world. But in the data lake world, it's not being given importance. And the last and foremost thing is that in the world of data warehouse, it's the structured data which is getting which is on which we are performing an analytics basically. But in data lake, we can store all kinds of data. We can store the unstructured data even, and we can even store the semi-structured data, right? So all types of data can be stored, but then the issue is that we cannot give a proper structure to the data, and that's why data lake lacks. But as we have seen in the last video, that the data lake house is best of both the worlds. Is the data warehouse and data lake brought in together to make the best, the most flexible, and the most efficient system. And over here you can see that the table format for data lakehouse, the table format is being given importance. That means we can perform versioning of on a data, right? Similar as we could do in data warehouse, but couldn't do in the data lake. The file format is there in both the system. The storage is there in both the system. Again, the goodness of data lake is also there, that there's a decoupling between the storage and the compute, and that's great actually, because you do not need to increase your storage in just in order to increase the compute, and vice versa, right? So that's the difference. And also the data lakehouse can process both structure, store and process basically the structured, unstructured, and semi-structured data. Okay, so these are the various kinds of things which, or these are the things which the data lakehouse tried to actually resolve, or yeah, basically resolve and provide the most flexible and the best OLAP architecture, right? OLAP system in order to perform analytics. All right, so in a final slide, we will just understand the advantages of data lakehouse, right? So, fewer copies equal to lesser drift. What does it mean? Basically, prior to the evolution of data lakehouse, the data lakes were there, right? So, what happened, that data lake could store larger chunks of data. So, what companies did, they tried to bring in all data to the data lake, okay, and then they brought in certain copies of data to the data warehouse, okay, which on which they wanted to perform the analytics, okay. And if they brought in the it brought in certain copies of data, of certain chunks of data to this data warehouse, what happened, that similar data was present in the data lake and also in the data warehouse. Now this kind of caused an issue in tracking the data, okay. So tracking issue was there, and this means that it was causing a drift in the entire big data analytics. Okay, so in order to avoid it, we the data lakehouse was brought into existence. And the data lakehouse actually resolved this issue, because not only it helped us maintain the asset properties of the data of the database world, it also helps us to store larger chunks of data, right? So best of both the worlds, fewer copies equal to lesser drift. Okay, and next, what happened? Faster queries equal to fast insights. Now, if the data is structured in a proper way, which is being done in data warehouse or the data lake house, what happened, even if the size of the data is huge, you can perform faster analytics upon it, right? And faster analytics means faster insights, right? So it's directly proportional, correct? Because the data retrieval is process becomes faster, right? With the help of the table format itself, correct? So and then we have the point of historical data snapshots equal to mistakes that don't hurt. What does it mean basically? As I've told you, that using the table format, you can roll back to your previous versions if you perform any kind of bad transformations on top of that data basically, right? You need not have a headache that your data has been that you have lost your correct data, right? So you can perform a version rollback, which you could do basically in data warehouse but not in data lake, correct? And finally, open architecture equal to peace of mind. And this is the point which data warehouse couldn't resolve, or data warehouse lacked at. Over there, every each of the component was tightly coupled, and this tight coupling basically kind of led to a scenario of vendor lock-in. But in data lakes, it wasn't the issue. Each of the components that was there in data lake house can be of different vendor, right? So the compute can be of Spark, the storage can be of Azure, the and the table format could be of Apache Iceberg or Hoodie. Like the vendor did not decide that that what is the table format or what is the file format, or the single vendor did not decide this, correct? So that's the thing. So these are the advantages of data lakehouse. So this video was related to the like dedicated to understand the entire architecture of OLAP workload and the differences in the architecture of these individual uh, systems of OLAP world, right? So thank you, and please do subscribe to my channel. Please do like this video. Please do share this video and all the videos on this channel, because I'm trying to bring up something new in this data engineering world, which other channels have not yet brought in. Okay, thank you so much.